Jacob Carlson, Kevin Crawford, Colton Davis, Maddie Gadeen, Andrea Granado,
Here.
April Grass, Chris Henderson, here. David Raymond is here, Hunter Lupton, Richard Maltby, Ethan Marshburn, Andrew Matlin, here. Matthew Madoko, here. Andrew Moskowitz, here. Juan Carlos, Denzel Peters,
Here.
Miguel Rosales, Tim Torres. First thing I'm going to do is well, I'll just sort of explain to you what my intentions were in terms of the work last week, and then look at the first project. So the goal of that exercise last week was was to be a review, like a super quick review of all of the basic components of C++ programming, with one kind of exception. So anyway, what I hoped that you encountered in there in some way is variables. And I mean, this is going to feel kind of weird because you're going to look at this and say, yeah, I'm supposed to know that stuff. But ask if there's some aspect of it that you're not connecting up the pieces. Now, you didn't really create any variables, but you did deal with data being expressed as variables. Examples would be parameters to functions, where you have to think in terms of the idea of the variable as opposed to an actual value of it. You also dealt with the data structure, which is, in a sense, a variable because it's a place where you carry data around. You may or may not. In yesterday's class, only a couple people registered well what the data structure was. This is actually the star of the show in one way. You remember what data structure that exercise last week had in it? You're close.
It's the array part.
Array.
Yes.
And specifically the standard template library array, which is sort of a two-step array with functions attached to it and stuff. But in a sense, it's a variable because it's a place where data is carried around. But it also was meant to give us an opportunity to practice some things around it, like checking index values to make sure they're valid, and also writing a loop to process the array. So decisions were in there. The way I compelled you to write decisions was I wrote tests that passed bad index values into your function. And if your function didn't have decisions to deal with that, then you failed the test. Does everyone remember that experience? Loops, although you really only dealt with one loop, it was a for loop to process the array. Have any of you ever written a for each loop? All right, most of you haven't, so I need to make sure that I show you a for each loop. It's a cool looping construct. Anyway, so by design, these things were there for you to encounter. You also encountered functions, because you had to implement functions, but the idea, again, was to kind of remind you what functions look like and how you write code into them and how you use the parameters, all that crap. And then classes. To sort of draw your attention back to how do we do object-oriented programming in C++. You did not create an object. I created an object in the unit test. That's how it worked. But I did sort of get your eyeballs on code representing a class in C++. So that was my intent last week, was to sort of quickly force you to encounter all these things real quick, to let you remind yourself what the syntax looks like for those things. I said there's one exception, and the major exception is pointers. You didn't have to do any pointers in there, which is the thing that most people find most difficult about C++. But I would argue C++ is just a shitty, garbagey language anyway, because there's symbols everywhere. There's brackets, and like, I'll just give you some examples. So what does that symbol mean?
Less than.
It's less than, unless there's another one, and now it means something else. Now it's a templated thing. Is one example. What about this one?
CN.
So you used it for couts.
Yeah.
But it turns out it's just called an insertion operator. But it doesn't mean that if you put integers around it, then it's the binary shift operator. And this is, I'm just sort of pointing this out to you as examples of C++ just all over the fucking place when it comes to its syntax. This symbol means what?
It's a pointer.
Or multiplication. It's also the way that you dereference a pointer, or define a pointer, or do multiplication. Depends on the context. Also, by the way, it turns out that it's an operator, which means that you can redefine it for your own purposes, which then means it has a completely different meaning depending on the context. Yeah, it doesn't. Pardon me. These are operators as well, which means they can actually be redefined in your code to mean something else entirely. The context is what's important, and you need to sort of train your eye to pay attention to such things. Like what's on either side of an operator matters. It changes what the meaning of the operator is. So if I have this, then you know that's the less than comparison. At least you can make a reasonable assumption about that. But if I have this, then you sort of have to reinterpret the meaning of the operator, right? Because now it's some kind of templated thing or something. Okay, anyway, so that's just recap last week really quickly. That was kind of the idea of that stuff. Were there any other questions hanging around out there from last week? All right, I'm going to look at the first project just to call your attention to a few things. The idea of the first project is that it builds upon the things that we're doing between now and then, and also then supplying some additional challenges that you have to solve along the way, which is just my approach for teaching programming. Sorry for the name, it's dumb, but at the time it was funny to me to call it the Raminator. I went to a big data site called Kaggle, where you can get massive amounts of free big data from the world. So what I did is I went and I found a ramen noodle rating data set, which are real ratings of real ramen noodle products from around the world. And I grabbed 2,500 of them. So you're going to write a program that loads all that data up into data structures and then sort of runs filters on it to look at the data in different ways. So I called it the Raminator because that was what I was on that day, I guess. That seemed funny to me. But anyway, and it's using a standard array, so some of those skills should apply. Anyway, so I'm going to look through these things, and the reason I'm doing this is because you should do this if you haven't already. Get a beat on this project, because these are the things that really, really matter when it comes down to points in this class, right? So you want to have a good sense of, do I think I can do this on the data that's due, or should I start now, if I can, and work my way up to it? So let's look at it and enjoy its part. There's another thing about C++, right? Is this mess. So here's all the libraries I'm using, at least the ones that I used when I solved this problem. And then I left my includes and using directives behind as hints to you about things that you might use. So these are the libraries, and then these are the specific classes that I'm using from those libraries. You're going to encounter this one new in your work this week, and I think this one as well new this week. But these are classes, so you can actually Google this, and you will find a page of documentation describing what these things are. I'm calling them classes, which means in your code what you do with them, typically with a class. We go above name. Functions there's a layer missing between using the functions of a class and a class. Objects. So if you have a class, you're going to need to make an object of that class. And now that you have an object, you can use its functions. So that's important to remember. So anyway, all these things you should think to yourself, well, if I'm going to use that, I'm probably going to have to create an object And once I have an object, now I have access to the functions that go with objects of that class. We're also doing this one this week. So this one you did last week, this one this week, this one this week, this one this week. Strings you're somewhat familiar with already. This one you should like when you see it. So just one way to start reading this project is what are the things in here that I've never seen before. That's at least gives me something I could go Google. How many of you have used enumerated types? All right, one of you have, most of you have not. So that might be a good thing that you can either ask me about during class or you can go look it up. Basically, this gives you a custom data type with custom values associated with it. And the idea is that then instead of saying that this is the value 0, I can use the word brand to mean that in my code, so it makes my code easier to read. Anyway, so that might be new, and if it is new to you, that's the thing you can put on your shopping list of I should go see what that is, because that is somehow a part of this project. Here's another one. I'm using a struct. So I use structs quite a bit in C++ programming. Probably more than classes, actually. So it's useful to know what's the difference between a struct and a class in C++. There's sort of an easy answer, and then there's a slightly more technically correct answer. Yeah? Kind of global. There's a better way to say that, but you're on the right track. Public. Public. So, but that's what you meant, I think. So by default, everything in the struct is public, which means if I create an instance of the Raman rating struct, like Raman rating, voids rating, I can do voids rating dot stars and publicly access that variable, as opposed to writing getters and setters if you've done that style of object in the program, which I do a lot. So that's true. Structs, everything by default is public, which is convenient because it saves you some extra function overhead. What about classes? Everything by default is private in a class, actually, which means you either have to purposely make it public to do this, or you write functions to provide access to it. But in all other ways, they're effectively the same. So if you see a struct in C++ and you see a class in C++, they're basically the same damn thing, which means that you can write constructors in structs, right? You can write functions in structs. You can overload operators for structs, which is probably the first time most of you have seen this before. So there's that operator, which you think means equivalency, but now it means equivalency of Raman ratings, which is whatever the hell that might mean. You can actually see what I defined it to mean. For two Raman ratings to be equivalent means that their review numbers, their brands, their varieties, their styles, the country of origin, and the stars in their rating have to be exactly the same. So there's two new things for a lot of you there. A struct and what that means in C++. Overloaded operators. There's two of them in here. So one thing you can say to yourself, it's perfectly fine to say is, oh, thank God he wrote them already, which I did. Because it's kind of early in the semester to ask you to write those for yourself, in my opinion, but you are going to be writing them for yourself in this class at some point. So there's your first look at those things. What about these things? Don't get overly calm. What are they?
True, false.
Comparison functions. Yeah, and they're just functions, right? They're not inside of a class. They're just functions. Have you all had the experience of writing just functions out there? Right, so that's all those are. This project has a struct with class with functions in it. It also has just functions out there. There's a reason for that, but for now. It also has a class. Because in this case, I thought that, well, in part just because I wanted to show you all these things in one place. In which you will see familiar things, get size, replace a rating, which you did what, replace item last week? Load from a file you're doing this week, filter you're doing this week. To string you did last week. So these are all kind of just iterations on the same idea. And then the standard array, which this time has 2,500 entries in it, and the entries are Raman ratings, which are instances of that larger struct, so you have to get used to that as well. So you don't have to say or ask anything about this now, but now would be the time to go have a look. Put together a list of, maybe I'll ask about that in class, or there's a dead moment somewhere to do so. I also have a private function in here, which I'm going to have you work on sometimes. Okay. Let's see what I do for the implementation. So look how generous I was. I do nothing. The implementation. Cats, you know. Unit tests, you know. That's just a way for you to confirm that your implementation code is working according to the basic needs of the program. Let's see. This one has a new feature called experiments, which I'm going to show you how to use this. But basically, sometimes it's handy to have a separate little side program where you can plug around and see how things work without affecting the rest of the program. And then this one has this gigantic gradings file. So there's 20, should be, I think, exactly 2,500 of them. But I also just thought you might feel satisfied if you actually worked with real data from the real world and did something like that. Then maybe you'll, if you're eat ramen noodles, then maybe you'll find a new one to try.
A lot of ramen noodles.
I'm just reading them right now. Pork mustard stem. I don't know what that means. Okay, anyway. That was just meant to be a quick save. Yeah, don't do that. I don't want that. Stop. That was just meant to be a quick heads up that that project is lying in wait out there for September 14th. That's damn fast if you don't start sooner than later. Some of it is challenging. Some of it is one-liner stuff that's easy to do, and other parts of it are challenging stuff. Be on the lookout, and the sooner that you start, then the sooner you can begin to ask for assistance on things that you get caught on. All right, all good on those things. All right, so the exercise this week, we'll look at the header and see what we're adding to the mix. The main thing that I figure we need to look at is how do you read data in from a file, which a lot of you probably already know how to do, but if you don't, I'll just sort of give you a helping hand getting started on that. And then from there, I will just ask, oh, there is one thing that I meant to. So, I don't know if everyone can see that. Is that as high as I can go? It is, but so I'm just, what I want, I'll just do it this way. All right, so this, where'd it go? Did I just switch it off the page? So this is going to be a trick question. So try not to use hard-coded values when you can avoid it. You have to create a standard array with the size. You just have to. That's the way it works. But if I ask you, how big is that array? How big is this array? There's a better answer. There's a correct answer, but there's a better correct answer. Because I saw a lot of you do this in your code, and it works, and it's not that big a deal, but you will thank yourself if you get in the habit. So how big is that array? 101. It's dot size big. It is dot size big. So try to think that way. Try to think in terms of not hard coding data where you don't have to hard code data. So if your implementation last week had hard-coded sizes in there, like if less than 10 or greater than 10, it worked. But it's not as good an answer as if greater than or equal to numbers.size or whatever it was. Why would you want to code your implementation to not be dependent on that hard-coded value?
Yeah, if that ever changed, you don't have to go through your entire work to fix it.
So, because if I want to tweak that number, now I don't have to also go to my implementation and hunt down all the thousands. And then what if I forget to do that? Then who knows what's going to happen? Especially if it becomes smaller than it used to be. Now I'm going to crash. So, if you're asking yourself, how big is a thing? Like if I ask you another example, how many characters are in that string S? At this level of programming, you should answer it the better way.
ASCII way or dot size?
Dot size letters. That's how many letters it has. S dot size is how long it is. Here's a trick. No. Anyway, so just revisit last week if you did that and just sort of look for where your hard-coded values. And, you don't have to fix last week because who cares? I'm not taking them out unless it bothers you. But this week, think about that. Why am I writing a hard-coded value here? Do I have to write a hard-coded value here? If you don't do it. Use a function or use a variable if you can instead. All right, so reading in stuff from a file, I wanted to point out that you should be using dot size where it makes sense to do that. Is there anything else that anyone wants to cover off this? I sort of left it on the screen, the thing that I figure people want to look at, but maybe I'm wrong.
For me, I don't know what I have questions on yet because I haven't got to use it.
Okay. I mean, we have both days this week, but one of these things might be tricky for people, so if we've gotten an early start, it would be okay. I'll do the file thing first.
Yeah.
And I'll do it kind of this is not robust, but the programming challenge is going to force you to enhance the code to make it so that I can't crash it with my unit test. All right, so I'm just going to fire up a program. What do I want to use? Can you see that pretty good? You can. I'm just doing this for my own. I think you'll be able to see pretty good. Yeah, doesn't that text look pretty good from where you are? All right, so let's see. What do I want to do? Hey! I'm unhappy.
Is your email working?
No, I updated Z shell and now schema doesn't work. That's all right. I'll just do it manually. All right, so the first thing I want to make sure we give ourselves an opportunity to ask questions about is reading stuff in from a file. This is sort of the first layer of this problem. It's just the basic, how do I do that? So I'm going to make a file. Yesterday we did animals, so let's do something else. Let's do, is it going to upset anybody if we do diseases? No, it's not diseases. Huh? Okay, but no spaces in the names of stuff. All right, give me a donut, please, donut. Can you see that word pretty good? Yeah.
Chocolate.
I'm purposely using an underscore because the code we're going to write will not be tolerant of spaces on the line. So just keep that in mind. It's a different problem if you do that. Jelly filled. There you go. I can get like 10. I can get 10. Can you take a 10 damn donuts? Custard?
Yeah.
Old fashioned.
Maple bar.
Careful. Oh, maple bar. Donut hole.
Careful.
Yeah, very close. This is an experienced donut crowd here.
Oh, what about powdered?
No one got the cake. I don't like the cake ones. My wife likes the cake ones. There's something wrong with it. You do?
Yeah. Oh, yeah.
Do you like okra too? Because my wife also likes okra. Which I figured was the same flaw, but maybe it's a different flaw.
Airtight logic.
Yeah. Well, because she'll say, oh, I don't like the texture of that thing. I'm like, you're eating snot. Texture, I refuse to believe that texture is the problem. All right, anyway, so the reason I did this is that now I'm going to save it as a file, and I'm going to write some code to read this file into my program. Got it? So here we go. I'm just going to save that. I'm going to save it as donuts.txt. Now I'm using my Mac, so I'm assuming that you're aware of the fact that you need to save these files in a predictable place. The important thing here is that donuts.txt is in the same place as the file as the program I'm about to create. So as long as those things happen, I'm in my temp folder. As long as those things happen, you will be okay. So now I'm going to create a new file, and this one will be the CPP file. So I'm going to include fstream. That's the file streaming library. And I'm going to include IOStream, which is the input and output streaming library. I'm going to say that as donuts.cpp. As long as the extensions are different, the computer doesn't care. Yeah. So, but that's, all right, so the question was, where does ifstream come from if we're using fstream? So the distinction here is that this is the library, right? And in my using directives, I list out what from the libraries I'm taking. So I'll be using cout from the IOStream library. I'll probably end up using the nline marker from the IOStream library. And then I'm going to use the input file stream from the fstream library. So that's where that thing will come from. So those are the, in this case it's a class, in these cases it's it's mostly for ease of reading. So that people can look at the top of my file and kind of get a sense of what I used here. So these are the libraries, and then from those libraries I'm taking these things. And ifstream means that I'm going to be using a file I'm streaming for input, bringing things into my program from the file. So is this going to work? No, it's not really. So the thing to put in your head here is we're talking about streams. And anyway, you actually have some streams experience because you've used this one. So this is called the standard output stream. And this operator is the one that you should be accustomed to using with the standard output stream to do output. So this operator is used when I want to do output to a stream. You're used to it being a standard output stream, and it turns out that I can stream things elsewhere for output. Does anyone use the input stream version? Yeah. All that really means is that I'm streaming data from an input source. The input source here is the standard input, which is the keyboard. Then that's the operator I use. In conjunction, remember that thing I was saying about the context matters? So the context matters. In this case, what it means is the data will come streaming in from the keyboard. In this case, it means that the data will go streaming out to the display, the terminal screen. You guys know the fancy terms for these operators? Insertion and extraction, which still makes sense to me because they're backwards. When I say that word, insertion, I want it to go that way. I just do. So I just had to get used to it and memorize it by rote. It doesn't really matter. If you can remember cout and cin, then those are helpful. So if I need to grab input from a stream, it's going to be this one. If I want to do output to a stream, it's going to be this one. So we're about to change the streams that we use for input and use a file instead, which means you're going to see this operator happen. And make a name. And then I'm probably going to need to bring up some documentation here. I'm going to bring up the ifstream documentation. C++ ifstream. And I should get a c++.com result, which is the one that I want. Making sure you can mostly see my screen. Okay, it's pretty giant, so I think I can back it off a hair, you still need. All right, so I'm going to use this thing. Input file stream. How did I know that? Because I knew that. You could, if you had Googled how do I do file input in C++, you would have found Livestream too. Even though it's not the only way to do it, so I'll show you how to do it for this class. It's a class. Livestream is a class, which means, it means I got to create objects. So let's just do that. Let's create an object for it. So how do you create an object? Class name, space, name of object. Object. All right, perfect. So now I have an Livestream object. Now, if you've already done it a different way, the constructor way, that's fine. I'm not going to do it that way here, just to force us to read functions. All right, so why did I create an object? Because I saw that Livestream is a class, and if I want to use it for stuff, I need an object of that class. So Livestream is a class. The name of my object is input file, so that's my thing that's going to be dot. Input file dot this, input file dot that. What we want to do with it, we want to open a file and get input from that file. So let's see if the universe cooperated and made it easy for us to open a file. By the way, I went to the public member functions first, because those are often the ones that I'm going to end up using. Sometimes inherited ones, but anyway. So is there something in here that looks like it fits the bill? Open. So I'm going to go look at that thing. Open. C++ 11 version. By the way, you're safe to do that in this class because we will always compile on the C++ 11. So we use the C++ 11 version. So how do we use it? Input file dot open. And then an argument or two. So we're going to put a string in there. Input or donuts.txt is the name of our file. So that's pretty clear, right? Give me a file name that's a string. Well, I do that with quotes typically, or a string object. What about this other bit? iOS space colon colon open mode equals iOS space colon colon new. So there's this one, there's sort of a technical answer and then there's an easy answer. Opening the file and going inside. The technical one is, do you want it to, the modes on a file are input only, or input and output at the same time. So you can probably guess what, all right, so that's part of it. That's what the modes means on a file. How many of you have seen a default argument to a function before? All right, so almost no one. I've seen one. That's true. There's a default argument to these functions. So here's we're interested in this one. Here's the parameter. The name of the parameter is mode, and then the type is this open mode thing, whatever the hell that is. That's the type. But what's this part?
Saying that's the mode.
Yeah, that's the default mode. So we call that a default argument. When a function is defined and a parameter is assigned a value, that's called a default argument for that parameter. What that means, though, is that parameter now becomes optional. If I don't provide a second argument, what value does it take? The default value. So if I just completely leave this off, this argument out, it's going to fill it in with input only. That's what I want, actually, because I'm just reading it for input. So that's called a default argument to a function, and usually we're happy to see those because that often means that we don't even need to worry about that argument. We just let it default. So the default is going to be open it for input, and that's what I wanted anyway, so great. So I only have to worry about this part for opening, which is the file name, which should be a string. So that's a default argument. You will see that often when you're looking at the documentation. Name of my object is input file. I want to open something. The something I want to open, I call donuts.txt. As a string, why? Because that's what the function wanted. so far not that big a deal, I think. I like the way Adam looks. That's a good color choices in there. All right, we're ready for the next part. So now the problem is we got to cycle through the file and read its contents. So the way C++ file streams work is they, well, the way this one's going to work is it's going to read one line and then wait for me to act on that line and then read another line and wait for me to act and so on. So there's no more lines to read. So the first thing I'm going to do is create a variable to store each line as I read it. I'll call it next line. So it'll start with the first line of the file, and then as I cycle through the file, it'll be the next line after that, and the next line after that, and so on. And then I'm going to use a loop. Which is pretty easy in C++ to do. Yeah. So all this says is as long as I can still extract a line from the file, I'll just keep doing it. At some point, there will be no lines left to extract and it'll stop. So there's the stream. Instead of the keyboard, it's a file. I'm going to extract data from it and then put that data where? Next line. One line at a time. So in the body of the loop is where I can do whatever it is I want to do with that next line. Which I'll just do something like CL dot next line. So it will actually recognize when there's no more left to read and just stop the loop. So what I should get is all of those, what are we, donuts, all the donuts that I typed into that file. And then good practice is once you're done using a file, close it. It doesn't always matter, but if you're not in a habit, then you'll find those situations where it does matter and you'll be frustrated. So once I'm done processing it, then I close it. So do you see what the program is designed to do, which is not much? Open a file, read it line by line, and print out those lines as they're read. That's it, right? And then close the file. So all I should see on the screen is the lines of the file with all the donut names. That's all it's going to do. Oh, with dot, remember. So dot glaze, dot chocolate, dot whatever. Yeah.
So at the close, you don't have to have an argument?
Correct. It'll just, so it will keep track of what you were opened on and just sort of close that out for you. All right, so there's that. I saved it. I'm going to do a manual build, so this isn't a bad time for you to practice this as well. Is that? Yeah, you'll be able to see it. This is Z shell, by the way. If anyone's Linux-y, Z shell is pretty awesome.
This is where we would do the shift right click.
Yeah, so you need to bring up your command prompt because I've already got mine up. So I moved from the editor over to my command prompt.
I've been doing this alongside you with Adam, so I'm kind of.
Yeah. Did everyone get all that code? How about I have to need to see the code for a sec longer? Everyone got the command console ready to go? So instead of using a makefile, we're just going to do a manual compile on it. And the way you do that is G++. So the makefile has these commands in them, but today we're not using a makefile. We're just going to manually compile. I'm using the C++ 11 standard. Now the file I want to compile, I call donuts.cpp. And then I'll go ahead and show you this part. I want the program that spits out called donuts.exe. So this is manually compiling, just by issuing the compiler command by hand.
Is that the same for a Mac?
Say again?
Is that command the same for a Mac?
I'm on a Mac, so yes.
Oh,
Yeah, it'll be the same. Should be the same for everybody. But yeah, this is a Mac, so you should have the same experience. And I think this is better in terms of being able to see the letters. So this is compiling my code, and the -O means output. The name of the output executable, the name of the program, when it's created, will be donuts.exe, I hope. Oh, darn it. This is easily fixed. Does anyone see what the problem is?
Include string.
Look, it's complaining about string, which usually means something easy.
oh, you didn't include the standard, the library or,
Yeah,
Yeah.
I forgot to include string. And I forgot to have a using directive for the string class. Yeah. So anyway, yeah, I got that compiler because I forgot that, and I forgot this. Then I'm going to save it, and I'm going to go rerun my compiler. Pop up a hand if you need to pause for a second on the code.
I really care.
We'll see what it is, because I may get the same one. I'm going to find out.
Oh, I typed includes.
Okay, let's switch over to and go to the compiler. Alright, so mine built way faster on my laptop than on this machine. So if you're on Windows, you just type donut.exe. If you're on a Mac, you have to do / or PowerShell or Linux. Yeah, anything other than Windows, you actually have to specify a path. But anyway, is that all 10? 4, 5, 6, 7, 8, 9, 10. That's all, so it works. So for some reason, I'm kind of going slow on this because in my experience, a lot of people really struggle with the concept of getting data in from a file and what that kind of means. But the whole idea is that you have to put data into the computer's memory so that your program can manipulate it. If it's sitting out there in a text file, you can't manipulate the data. Right? So you read it in from a file, get it into memory, and then now you can begin to do stuff with it. Although all I'm really doing is getting into memory and spitting it out and then overriding what the memory is doing. Questions about that? Just yet? Oh. All right, I want to make another file and just show you one more example that I think might help. So I'm going to create another text file with numbers in it. I don't know, man. Spit out some less than 100 numbers, and that could be negative.
Negative 300.
Negative 3?
Yep. 300.
29, 24, 13, 0, 17, 54. I'm gonna make it negative 38. No, I wanna make the 18. It can be useful to put, do you know what boundary values are? Zero is a sort of a classic boundary value. That's that crossing over point between positive and negative. So negative 1 and 1 are also boundary values. So getting a 0 in here is not a bad idea as a test. So this is more like what you're doing this week, where you have a file that has numbers, not donut names in it, right? I just want to show you what you need to change in your code. The first thing I'm going to do, I'll save that as numbers.txt. And then I'm going to go into my program. Oh, I'm already in my program. I'm going to change, instead of opening donuts, I'm going to open numbers. And I don't even think I'm going to run the sample because I think there's enough information for you to work with here to sort of detect the problem.
Yeah, I got my EXE to work. I'm not where you are, but how do I get it to? I'm gonna get an error, but how do I open it? I didn't see
How do you run the program?
Yeah. Thank you.
Right, so it's numbers now. You get the basic idea, the difference between a string and an integer in C++. What can you do with integers that you can't do with strings? Math and meaningful comparisons. So right now, if I run this program, it's going to load that numbers file, and it's going to print them out, and they're going to look like numbers, but I know they're not. What are they actually? They are strings. They're coming in as strings, which is how I've written the program, is reading in as strings. So you got that? Which means that even though that's going to say 58 at some point, it's not 58, it's 58. The string 58, not the number 58. So that's kind of a pain in my ass if I want to do things like math or meaningful comparisons of numbers and not strings. So the question is, what do I got to change here so that I'm getting numbers and not strings? That's correct. The C++ can work out the rest. So if I have a different data type on the lines of the file and I need it to be what it is, like floats or ints, all I have to do is extract them into that data type, and C++ is capable of that. So it's going to look like the same output, but I know that what's true now is that they're numbers. In fact, we can fart around with it if we want to, and just output each one bigger than it actually was. Because they're numbers, and I can do that. Hell, I can do it 10 bigger. I can do 1,000 bigger than they actually were. So you have to be careful when you're reading input from a file that at some point it becomes the kind of data that you need to do your work. If you need numbers, then make sure that you're reading them in as numbers. If it's okay that they're strings, then read them in as string. But just keep that in mind. Now, we have more challenging ones than that even. So I'm going to go back and I'm going to recompile. It's actually the same code, the same program, it's just changed some of the code. And then I added 1,000 to them, so they're all 1,000 bigger, just to prove that I could actually do math on those values. Yeah. So that's part of your sort of bigger problems. There's a more challenging one lying out there in wait, which is what if one line of the file has a bunch of different kinds of stuff and I got to break it apart? That's another problem to deal with. Right now it's just one line and one thing, and you don't have to break it apart. Just read it in correctly. But eventually you need to be able to read in a line that has a whole bunch of shit, like a Raman's gradient set. The what? Hey, that was the question I wanted to hear. The question he just asked is, where is this? How do you do this? Has anyone done that already? That would have been impressive if you did. This is a pretty new feature of the C++ language. So we're at sort of my lecture time, but I'm happy to go on if anyone wants to see this. I personally actually find that, so your work with this is actually quite easy. If I let's kind of show you the entire thing, how it's meant to work, that might help. And it looks like crap, but it's a fucking cool thing. It's cool. So what this is, well, let me tell you where it came from. So the reason for this include is that. So I included functional, and then from functional, I'm using a function. You guys know that YouTuber guy, fun function guy? Yeah. He's a web developer. All right, anyway, so that's where this function came from. You've actually seen this syntax before. Template. So it's a template. It's a weird looking template, but it's a template. That thing just means by reference. Don't worry about that. So the fancy word for what we're about to do, and I'm going to build up an example from scratch. These are called Lambda functions. Or usually people will just encode, say, lambdas, which sounds way more mathy than it is. But the idea of a lambda is that you can actually declare a variable that is a function. If that makes any kind of sense. But if you're going to declare a variable that's a function, then you can pass that variable into another function. So this is passing one function into another function. The function's name here is f. But that's what lambdas were kind of designed to do. If you Google lambdas or lambda functions, on Wikipedia, they have an entry for them, but they call it anonymous functions. They're not truly anonymous, but you'll see that there's a whole bunch of languages that support it. So let me show you one that does it real pretty. This is a pretty lambda function. And then we're going to look at shitty ones because that's the way C++ does it. But anyway, you notice it's kind of like not a function with a body like you're used to. It's a variable called sum whose value is a function, which is kind of a weird thing. All right, so let's do a sample because they're kind of fun to deal with. What am I using? Atom. All right, so I'm going to make the program. Let's see, we're going to need the functional library, and we're going to want IOStream, and we may want strings, so just to head that off, I'm going to include that. I will call this, yesterday they wanted to call it funky. Does that work for everybody? Just the function stuff? Or we could call it lambda. Funky stuff. I'll post this stuff if anyone wants it, by the way. So I'm going to show you kind of what I set you up to do, and then show you your job, which is relatively easy by comparison. But I think it's probably helpful to see where it all came from. So anyway, I'm going to make a program called funky.cpp. What those includes using directives for I may want these I don't know about, so just in case. I want function class, and I want strings, which I'm not sure if I'm going to use them, but let's have them just for let's see, what's a cool, like Raminator? What's a cool thing that's been on the back end of a word and make it sound funny?
Generator.
Oh, shit.
And so I'll call it like doinator. The doinator 3000. You'll see what I mean in a second. Doesn't really matter. That's the name of the function. It's a silly name for a function. Right? So the parameter will be another function, a templated function. That just means it will be passed by reference, which we don't really have to do or worry about. But anyway, the parameter to the doinator is another function called f. Okay, so far? That's just it. Some other function, who I'm going to refer to as f. And the basic job of this function is going to be to invoke that other one. Now, I've got some blanks to fill in, but before I start getting unwieldy, this function's job is to make another function work. That's it. So the doinator invokes f. What is f? Some function. What function specifically, which is the hard part? Yeah. Don't know, don't care. It's some function that someone gave me. Which I will sort of indiscriminately just fire off and hope for the best. But it's true. All right. So okay, so far. This is a lambda function. We actually hadn't done the lambda function part for receiving. But when you define a function like this, you also have to specify its return type and arguments list. So let's say that the function that we want to receive, this f, will be a void returning function that takes as a parameter a string. So now the doinator now does have rules. If you're to give it a function and it's going to fire it off, that function has to return what? Nothing. Void. And take as a parameter a string. That's the rule, right? So if you give me this f, that f needs to return void and require a string. Okay. So if I fire it off, that means I have to give it a string, which I'm going to do. I'll just say donut for starters. I still don't know actually what that function's got to do with this string. But I'm not worried about it. My job is to make sure that that function can do its job. That's it. Very indirectly. Makes sense so far? A little bit at least. Now let's do the scary part. That's the easy part. Now the hard part. So now I'm going to define my lambda, which is my semi-anonymous function, which will be a function which will return void and take a string. I will call it I don't know. Let's try the what would be funny at the end of donut? Donut.
Donut face.
Okay, face.
Face.
All right, so one thing to note here is, so I'm actually creating a variable that's a function. The name of that variable is face. It's a function that's going to return void and take string as a parameter. Now, the reason I did that is because it matches the signature of the doinator. Yeah.
What is the purpose of the ampersand?
It means that this will be received by reference, which actually you can take off and it still works. So in this case, all it does is gain a small efficiency in terms of being a reference to the original block of code as opposed to a copy of it. All right, so face. So this is actually the data type of face, and the name of it is face. And then the way you define these things, I'm going to do it on the next line because I think it's a little bit easier to track. So here's the definition. And let's see, what do I want this to do? Oh, yeah. So this function, if given a string s, will print out the s and say in your face. At first, once we've done a couple of these, you'll start to sort of feel better about it. That is the C++ Lambda function, which Wikipedia calls an option. The name of this sort of function as a variable is called face. What it does is it takes a string, which I'll refer to as S in its definition, put that S and say it in your face.
What I'm confused about is in your donator, you have F, but there's no F anywhere.
There is, it's right here.
Right, but that's supposed to reference what you just wrote.
Oh, so now, I say donator, do this.
You just keep donuts in your face.
That's what I want.
Okay.
I mean, I like donuts. So if there were any donuts, I would have them in my face. So I'm passing face as an argument to the function, which the function just refers to as f. Passing it by reference really just means that I'm gaining a small efficiency in terms of the use of memory.
So,
but yeah, you're right. It should say donut in your face if the world is working right. But let's try it. Go ahead and ask the question. I'm going to compile.
So is using F kind of like using I in a for loop? Like it's not necessarily a big deal what you're labeling as?
Yes, that's correct. So I personally use F because I think, oh, that's the function. F, whatever it is.
And that's easy.
Yeah. So now in theory, it should say donut because it should do that. Kind of fun.
So how come it doesn't have S?
Oh, because I called it with just donut. But I could put the S on right here. So now it would say donuts in your face.
So the F turns into S.
Yeah.
So why does it say C out S? Is it because you wrote string S? And that was just a random choice for you to label that
I
string?
called it, yeah, it's the parameter to this lambda is S.
So that's not, why does it not say in your face twice then? Does S even have anything?
No, it does. So if you trace it, so what is face? Face is a function that takes a string S and prints it with that S in your face. So that's all face is, something in your face. Okay?
Right.
So now I'm going to ask the doinator to execute this. So the doinator gets it, which refers to as F, and says, oh, it's a function that takes a string. Which what happens if I say donut here? So what face then does is face with the argument donut. So donut in your face. Pretty tricky. Let's do another lambda on that one, and then we'll do a sort of more realish one. So we can do another one. The important part, the doinator requires that this be a void returning function that takes a string. Right, that's what the doinator wants. I will call this party. So I'm going to do another lambda. I'll call this one party. This square brackets is just the syntax in C++ for defining a lambda.
Could you also just write string S there too?
No.
Or you would want to write like string P or something?
Oh, I can call it string whatever I want. Yeah.
I don't know why I'm so concerned to see out. Fit out.
It is. Some S. When I write this, I actually don't know what the doinator may do.
Okay.
So all I'm worried about at this moment when I'm writing this code is, what do I do with my string S in the party function? And I'm going to say S party. So the face function just takes the string S and says that string in your face. The party function takes the string S and says that string is party. Which is kind of you have to sort of do some mental gymnastics here. Because at the moment when I'm working on the party function, I'm not worried tons about what doinator actually does. That's its problem, not mine. So anyway, about the doinator, I can say that if I pass it a function that matches that setup, it'll do something. So I did the doinator on face, I'll do the doinator on party.
Even as string s, you can do both of those. And not need to comment out one.
Correct. Because they're independent functions, independent lambda.
Now, is that also just like using I in for loop, it's just like the common thing?
Yeah, this is just me being lazy because I didn't want to name it.
Okay.
So, and I didn't really think, I couldn't think of a descriptive label for it, so I just used S. S for some reason. Like I is kind of for integer or iterator. So now it should say donut in your face and donut party if things work. Right, so that's sort of not useful lambdas, but just so you can sort of see them get built up from the scratch.
On the way you're happening. Right now, you're happening.
Strings, yeah, which, you know, is just a toy. Now I'm going to do something that attempts to be a little bit more useful. All right, everyone with me so far? So let's add, well, what do I want to do? I'll just add stuff.
Could you do that with BizBuzz?
Probably, yeah.
So you could have the doinator be the function of like doing BizBuzz, and then your void functions in main are the numbers that you want to pass through. That's the biz in buzz.
Possibly.
I'm trying to reference to something that I've done a different way that could be done this way.
You could do it, but I'll do an example here where I think maybe you can make sense of why you would ever do such a thing, other than it's just a cool fact. Yeah.
I was just gonna try to kind of explain it using a list. Understand it too.
Go ahead.
The way that I kind of think of it, as concatenating them together, so because you put two strings in there, you're gonna get this.
That's true. I mean, it's kind of separately, right? So two separate function calls.
No, the two strings, you have, the string S is gonna be donut, so
That's
you're
right.
always gonna have the two.
I'm not sure if I follow.
You have the string S,
Yeah.
and then you have what you're adding to it in your face.
Right.
And then string S, and what you're adding to it, party.
Yeah. That's true. And these are just functions that look weird. It's just a function that takes a string and prints out that string within your face on the back of it. So here's a more useful example. Let's say we have an array. So I'm going to include the array library and then using standard array, which would be pretty close to what you got to do this week. So I added an include for the array library and a using directive for the array. Now I'm going to add something that seems a little bit more useful maybe. So just out here in the global space, I'm going to make an array of integers. Let's just say there's 10 of them. I'll call it nums. I'll call it numbers. I'm being lazy. All right. Can I just use that same old list? I'm doing this to slow myself down. So if you wonder why am I doing this the hard way, it's to let people catch up. Nope. Almost. This is the same numbers from that file, because I didn't want to make up new numbers. 38, come on, 38. All right, so there's an array with numbers in it. So I'm just going to call this one the, no, I'm going to call this one. I'll just call it do array stuff. So now the purpose of and what I wanted to do is take a function. Starter. So you're on kind of with me a little bit. So this is a function. It's going to take another function. We'll worry about that in a second. But what I want to do in this case is I'm going to make this function, the array stuff function, fire off this function for every element of this array. So let's just say, for example, we have a void returning function. The elements of the array are integers. So I'm going to pass each element of this array to another function, which needs to take integers because each element of the array is an integer. That's the starter. But what it's going to do is cycle through the array and fire off that function with that element of the array. So for each integer, which I will call n, in the array numbers, do something. That's it. Yeah, it's awesome. You can also, by the way, that reference thing, someone asked about reference. If you need to alter those numbers in place, you can do it by reference. But we don't, the rest of us. So it's going to cycle through the numbers array. For each n in there, it's going to pass it to this other function. That's what it's going to do. So then the question is going to be what, hopefully, you would, well, what is that function going to do with it?
We don't know yet.
Don't know yet. That's right. Nothing that returns anything. I know that much. It's going to take a number and not return anything. That's all I know. So I'm just going to cycle through and fire it off and see what happens. Got it? Now to see that in action, of course, we're going to have to create some lambdas. So I'm going to create a lambda. It's a void returning function that takes an int as an argument, which kind of matches what do array stuff wants. I will call it, well, we could look at the, we can find odd numbers, for example. So the int I will call, I don't care. What do you want me to call the int? Locally. Okay, x works. So take that int x and do if x mod 2 is not equal to 0. I will see out the x and is odd. So it's a filtering function, if you can imagine it that way. So the only reason do array stuff exists is to help me with the process of applying different filters to that array. So in theory, if I pass this function into do array stuff, you get the idea? So do array stuff and give it odds, which will serve as a filter for odd values. So what array stuff does with odds is it cycles through the array and calls odds on each value n in the array, which I call x count. So if it's odd, then it'll print out the number and say it's odd. It's good. Yeah.
What is the empty brackets? What does that achieve?
That's the required syntax for defining a lambda in C++.
And then, for each, so that reads to be for each integer n from numbers, do this.
Do this to that n. Yep.
Okay.
Which means that every n gets processed. That's pretty cool thing.
Yeah.
You work? I mean, I have to check the numbers, but probably those are correct. Maybe 3 is on 99, 13, 17, 55. Does it leave anybody out? 17, 55. No, it's correct. What is the function of this? All right, I'll show you one more variant that's a little bit closer to what we're doing in class. So the reason why I create these is as filters. And what that means is that this is a swappable filter. So what am I filtering for right now? Odd numbers. And it would be very easy to create a filter for evens, would it not? Because I could just
rename it even and change your.
Yep, so I could rename the lambda to the evens and just say if that equals 0, x is even. And now I can do array stuff and apply that filter.
So that's why you could also like filter for grades. If that was like 10 people's papers.
Be good. We'll do one of those just as an I'll do one more example. So if you have the patience, we'll do one more. The one that was likely to help you the most. Probably this is correct, 2402, -1838. All right, so here's one other way, the way that you're going to do in this class. So let's say apply filter. This time I'm going to take a function that returns a bool when passing in. For each loop, for each n in numbers, if applying that function n returns true, I will see out true for n. This is going to require a different lambda. But it turns out that if f returns something, then you can use it. So in this case, f is a function that takes an integer as an argument and returns the bool result. So when I invoke f with those integers, I check if it returns true. And if it returns true, then I'm going to do something. This is the one that's like really close to the file. And then I'll write a lambda for that one. So this time the lambda is for a function that returns bool. I will call it A grade. That's the required syntax. I'm going to get some index. And I will return the result of evaluating x greater than or equal to 90. Which, by the way, is a nice sort of compact style of programming. So I just return the result of that evaluation, which will be true or false. True, it's greater than or equal to 90. False, it's not. Which is a nice succinct lambda. And then I will apply that filter. Which will take that as a filter, cycle through the array, and then check everywhere where it's returning true, that filter, it's going to point that out. Which should only be for 99, right? Although let's go into wacko world and make a be greater than or equal to 50, just for fun. I'm going to give you, on the exercises in the project, you have multiple opportunities to experience this. Does anyone want me to load either or both of those? Please. Okay, so I'll put both of them in our But actually, there's some from yesterday already there. So if you go to the file section of our website, you will find examples from yesterday that we pretty close. The reason why Lambdas, by the way, is because it's modern programming, and you should learn some of the modern techniques. The Lambda functions are a modern programming technique. Yeah.
Could you just go back into your file?
Yeah. I'll load this one as Lambdas too, but the file reading one should be enough already to called file IO.cpp. But I'll do a Lambdas 2. So that this one gets out to that's a lot of communication with that. So I'll be gathering questions and addressing questions. I've got a thing on my menu for the separate whatever you've got as well. That we can work on together. C++ doesn't do it super good. Just gotta do it work. Actually, just come on my laptop, I can probably just get this up there real quick. What program?
Oh, it's a Swift, okay.
Oh, yeah, we can do that. Yeah, we can do that. I can just go grab it right now, probably. All right, so then, if you go to the file section, the Lambda examples from today are up, and there's a file IO example from yesterday. Let's make sure that they are readable. Yeah, I can. You don't need anything on the. So the source files are up in the file section of our website. Where's the monitor? You want to do that now or later? Okay, so. What's that? You know, so all you have to do is write the filter function. So that's one of those. So now you know what that F is likely to look like, but you don't have to write the F for lambda. You just have to apply them. So you're doing the application. Well, you're going to have to cycle through an array, and this class has one in it. That's part of it. But your job is to cycle through your array and apply F to all the. Now you probably have to, like I think if you read the documentation, it will tell you what you want to do with those results. Okay, so if that F returns true, then you want to add that to your output list. C++ is not recognized as a program. So have you installed NGW?
Yes, I have. I remember last week we put it in the environment for,
Yeah. Yeah, it probably is, it's just not on your path. So let's go hunt it down and grab that information about where it is. Yeah, we'll just search it down. Yeah, we'll go to, just go to the C drive and let's hunt it down. It's not hard to find. GW, then, all right, click in the address space and copy this. Copy. All right, now we'll go edit system environment variable. There's a button for environment variable. I would edit the one at the bottom. So scroll down until you can find path. Yeah, so double click it, just edit it. So, wait, it's already on there.
Yeah, so last week we did that for the AW.
Yeah, and that's where G++ lives, unless you don't have it. Actually, you don't have it. So do you have the installer for this still?
I can delete it, so.
Okay, so it's probably in your downloads then. So just go rerun an MGW installer from downloads.
Okay.
So you can close that, you're okay for path. It's just that G++ itself actually isn't installed. Oh, your downloads are this, it should be in your downloads. Alright, that. Yeah. Yeah. Do a reinstall. And it should come up with a dialog that lets you select packages.
Okay. Do you think I just didn't like select?
Yeah.
G++ when I downloaded it last time? And this won't change the path that we said.
They won't, it'll just add new stuff in there. Yeah, continue now. Okay, so, you got base. Yeah, we'll grab that, that, mark installation. So go ahead and, if you go up to installation, I think there's an apply. Yeah. Like that shouldn't take too long. And then we're gonna go look in that folder here and see if it actually arrived.
Okay.
Go through that. Go back to that. All right, so now it should just work. Okay, it took.
Okay, cool. Thank you.
Probably, let me check that. What's your name? Cyrus. I didn't check the system since before Friday last week, so we'll just make sure we're doing it. That's best to know for sure. It's Tuesday, yeah. Okay, you're on there now, so I'll add you to my localized ones. Cool. Here next. unused parameter. So don't define a function in a function. Well, you're already in a filter function. So why is there another function beside this? Get rid of that. Okay, so now just write a loop to cycle through your array. And the for each loop is super easy to this, you don't have to use it. Well, it's called number switch here. Good.
What I didn't realize was, this.
Yeah.
Thank you.
Don't need a loop there. You just get in an index, you go back to the array. There's an array, if you have an index, it's repeated. Yeah. But remember that it's likely to try to give you bad indexes. So it's the same as get item from last time. That's right. That's good, it's gonna work. Did it work? It did, thank you.
So Void, I was trying to run MinGW on here, and I installed all the packages, but it's still not working.
It's MinGW32-make.
Oh, dash make. MinGW
W32-make.
Yeah, still.
Okay, well, let's go see where it's installed first, and then we'll fix paths.
It's in here. And
Okay, and then bin.
bin.
I've got a bin. All right, so grab this address, click in the address bar, and copy
Okay.
that.
Right.
All right, now let's go to edit environment variables. So go to the search bar and start typing environment.
Environment.
Not there, the search bar.
Okay. Environment.
Environment, one of the choices will be edit the system environment variables.
Okay.
It probably just, yeah, it's that last one, it just didn't.
Oh,
So
okay.
there's a button for environment variable.
Okay.
So find path in the bottom list. Let's do the bottom list.
Right there.
Yeah, edit that.
And then just new.
Add a new entry,
New.
and then paste that stuff in.
Okay.
All right, and then okay.
And then try this again.
Yeah, kill that. So it won't work until you kill it and
Okay.
restart it.
I'll do that.
Yep. now
There it
works.
goes. Thank you.
Should be the last time you have to.
And then the G one I also got right.
Oh, does it? Yeah. Try MC 146. Okay. It's supposed to be that, but I've found that it's not always. Oh, and if you want to know, by the way, the instructor station is MC 146I. It's the same pattern on the entire campus.